Next concept is views under model 4. Views means we can define view as a capturing the structure. You can think of as a view means that is capturing a structure which provides us with the basic principle of documenting the software architecture. Means that is for documentation, it means views are necessary, means because they were providing a basic principle for documenting the software architecture. And documenting an architecture is a matter of documenting the relevant views and then adding a documentation that applies to more than one view. First thing is, first we'll add relevant documents. Next we'll add that is more than one view. Afterwards we'll add that is the document which are not more important. That is it is like when an analogy for this is first when we go to market, first we'll purchase the necessary things, necessary that is eatable items, then we purchase what, the other items. Like this that is in the view also, first the necessary, the relevant views will be documented, and next other views will be documented. And this principle is useful because it breaks down the problem of architecture documentation into more tractable parts which provide the structure for the remainder of this chapter. That is choosing the relevant views, documenting a view, documenting the information that applies to more than one view. That is first we'll choose a relevant view and we'll document that, and documenting information that applies to more than one view. Choosing the relevant views. How to choose these relevant views? A view simply represents a set of system elements and a relationship among them. What the view represents? It represents a set of elements and the relationship among them. So whatever elements and relationships you deem useful to segment of a stakeholder community constitute a valid view. Here is a simple 3-step procedure for choosing a view for your project. Produce a candidate view list. How to do that? How to produce a candidate view list? And this is begin by building a stakeholder and view table. This below table represents the stakeholder and view table. Your stakeholder list is likely to be different from the one in the table as shown below, but be as comprehensive as you can. This is a smart table that is with you can quickly view the whatever the stakeholders and views are required here. Apart from that, we can build a comprehensive tables. For the columns, enumerate the views that apply to your system. Some views apply to every system, while others only apply to systems designed that way. Once you have rows and columns defined, fill in each cell to describe how much information the stakeholder requires from the view, none, overview only. Let us see this table, that is table representing the stakeholders and architecture documentation they might find most useful. Stakeholder is here project manager. This is the stakeholders, member of a development team, testers and integrators, maintainers, product line application builder, customer, end user, analyst, infrastructure support. And the first column is model views, CC views, allocation views. Under model views we have a decomposition, uses, class, layer. Under C and C views we have various allocation views, deployment and implementation. classify these views into two types, that is combined views and collector views. Uh, the candidate view list from step 1 is likely to yield an impractically large number of views, because it will not reduce the list, because to reduce the list to a manageable size, first look for views in the table that require only overview depth, that serve very few stakeholders. See if a stakeholders could be equally well served by another view having a stronger consistency. Next, prioritize is after step 2, you should have an appropriate set of views to serve your stakeholder community. At this point, here we need to decide what to do first. How do we decide depends on the details of a specific project. But remember that you do not have to complete one view before starting another. People can make progress with the overall level information. So breadth first approach is often the best. Also, some stakeholders' interests supersede others. Next important aspect is documenting a view. How to document a view? In the previous sections also discussed what is a view. View is a description of a structure. It is a detailed description of a structure or a model. The document view can be represented like this. That is a primary presentation, element catalog, context diagram, variability guide, architecture background, glossary of terms, other information. Like this we can represent a view with a documentation. That is a primary presentation. Elements and their relationships contain a main information about these systems, usually graphical or a tabular. Elements and their relationships contain main information about these systems, usually in a graphical or a tabular form. And element catalog, details of those elements and relations in the picture. And context diagram, how the system relates to its environments. And variability diagram discusses how to exercise any variation points. A variability guide should include documentation about each point of variation in the architecture, including the options among which choice to be made, the binding time of option. Some choices are made at a design time, some at a build time, and others at a run time. Means once the architecture is designed, in some cases specifically at the when we are choosing a customer when we are documenting a customer feedback, in that case we require some verification in the architecture, so that will be taken care by this variability guide. At what stage, at what time the verification is made to the architecture. That is variation, not verification. Variation is made to the architecture. That is binding time of the option, or at a design time, or at a build time, or at a run time. And next is the architectural background. This is under documentation view, why the design reflected in the view came to be an architectural view. That is, it may be a rationale explaining why the decision reflected in the view were made and why alternatives were rejected, and analysis result which justify the design and explain what would have to be changed in face of modification, and what are all the assumptions reflected in the design. And next is glossary of terms. The glossary of terms, it represents for representing used in the views with a brief description of each term. Other informations include management information such as authorship, configuration control data, change of histories, or architecture might record references to specific sections of a requirement document to establish a traceability. This is how the view can be represented. Section 1, section 2, section 3 up to section 7 we can represent a view. The first section is a primary presentation of the view, that is a textual version of the primary presentation. It contains a textual version of the primary presentation. And section 2, it represents a element catalog, that is elements and their properties, relations and their properties, element interfaces and the element behavior. And next, construct diagram, it represents how the system behaves in a various context, at a runtime, at initialization time, at development time, at like this, at different phases how it behaves. That is a context diagram. And section 4 represents a variability guide, means what are the variations that to be made to the actual architecture built. And next one is section 5, architectural background. It represents a design rationale and analysis of results, and what are the assumptions made while implementing models. And the last one is a glossary of terms that are used in this documentation and other information that can be added in the section 7. And next section is it represents documenting behavior and documenting interfaces. This I will be continuing in the next video. Thank you.